Okay, class, let's finish the last page of this lesson. Number 20. Does the radical equation 6 plus the square root of x equal 1 have a solution? Explain why or why not. Okay, sometimes we like to throw the constant in the front just to annoy you maybe, or just to make you realize sometimes constants can be in the front as well. So I'm going to subtract 6 from both sides, and then I get square root of x is equal to negative 5. So I know mathematically we can continue. We could actually square both things and we would get 25 for our answer. But you have to be very careful because if you plugged in 25 back inside, you should be getting 5, right? If I were to square this and square this, I'd be getting x is 25. One other thing you should also realize is the square root of a value should never have a negative output. So this is no solution, and I'm going to go ahead and write this. The output for a square root must always be what? It must always be positive. And it has everything to do with what we've been talking about in the last two lessons. It has everything to do with the fact that this is a square root, and a square root is an even number. So therefore, this is already a no solution. Okay. The next 6 problems I think are excellent. You may run into a no solution portion. You may run into something that doesn't exist, something like that. Always make sure you understand what type of root you are solving for. If you're solving for the square root, then you know that it's a little bit more strict with the rules. Whereas a cube root, you know that any positive or negative for a cube root will always exist. So I love this section. I think if anything, you should pause this video and just try these 6 problems yourself, and then push the play button and just see if you got it right. So I'm going to do 21. You add 5. Remember that the constant is always, it seems like the constant is always that first step, right? So then you always want to write what is left over as a next step. You don't want to do 2 steps at once, especially when we're dealing with roots and stuff like that. So now you should think of this portion right here as kind of like a question mark, right? 7 times this whole thing is going to equal 14. So you kind of know that this square root of x plus 3 has to equal 2, right? Because 7 plus 2, or 7 times 2, is going to equal 14. So I'm going to divide both sides by 7, and we get the square root of x plus 3 is equal to 2. Well, I mean, there are so many ways you can think about this. What do you think x has to be in order for this answer to be 2? Well, we know the square root of 4 is going to equal 2. So we kind of know that this expression has to equal 4, right? But I'm still going to show it. You square both sides, and you get x plus 3 has to equal 4. And then you subtract by 3, and you get x is equal to 1. Okay. I'm going to check for maybe 2 problems, but in the interest of time, I'm not going to check all of them. But checking just means to plug back in. So 7 times the square root of 1 plus 3, which would equal the square root of 4, minus 5 is equal to 9. The square root of 4 is 2. So then 7 times 2 would be 14, and minus 5 would give me 14 minus 5 is 9, and we know this is right. Okay? Checking just means to plug in your work. Check. Just plug in your answer to verify. Okay, so let's move Let's move a little bit faster. So now we're starting. This is really where the honors curriculum kicks in, right? Do we know how to do 2 minus 2/3, and can we do it very, very calmly and confidently? -4 square root of x is equal to 2 minus 2/3. Well, 2 is 6/3, so this is 4/3. Already I'm having somewhat of an issue. I already noticed something that's a little bit weird. And it's kind of like saying -4 times a something has to equal a positive. Well, that's weird because the square root of x should always be positive. There's no way that this could ever be negative. So how does -4 times this equal a positive? Immediately you should realize that doesn't make sense. So I'm going to divide by -4, but actually I don't like that step. I'm going to do something a little bit better, which is multiply by -1/4. Multiply by -1/4. Remember, you can always multiply by the reciprocal to cancel a coefficient. So the negatives cancel, the 1/4s cancel. You get square root of x is equal to, let's cross simplify here. This becomes 1. This is -1/3. And that brings us back to number 20 again. How in the world does a square root of x ever equal a negative? The output for a square root must always be positive. So this is immediately no solution. You kind of expected no solution to pop up somewhere, and it popped up in the second problem. Okay, 23, cube, everything. Remember that when you're cubing, you always want to include the negative. If you forget the negative, well, technically, I mean, you will be okay. I don't want to go into why you will be okay, but just remember that. Get into the good habit of using parentheses whenever you cube something. And you get b plus 5 is equal to -8. Here, you definitely want to double check. You definitely want to make sure. In future math classes, you'll hear about something called extraneous solutions, and that can be very, very scary. So you definitely want to check. But you get b is equal to -13. So far, so good. I just want to make sure that this is okay. So now I'm going to plug it back in, and I'm getting the cube root of -13 plus 5. Did I do anything wrong? No, that's fine. And then this is equal to -2. So -13 plus 5 is -8. The cube root of -8 is indeed -2. Remember, cube roots can be negative. Nice. Let's go subtract 7. 2/3 square root of a over 4 is equal to 2. You multiply by 3/2 to cancel out that 2/3, and you get square root of a. Now make sure you write a and it doesn't look like a 9. Even to my eye, that looks like almost a 9. A over 4 is equal to 2 times 3/2 is just 3, right? Because the 2's cancel. So then here you square both sides, and you get a over 4 is equal to 9. And then you multiply both 4 on the top and the bottom. So then you get a is equal to 36. Now again, you don't have to think about positive or negative. The only time you have to think about positive or negative is when you're solving for x squared. X squared equals. Here we're just using a, and we're squaring both sides, but we're not solving for x squared. We're just solving for an original a or an original b, right? Here you would have to be careful for the x plus or minus. Here you don't have to be careful. So just keep practicing and make sure you understand reason why and why not. Okay, I'm going to skip the check for this in the interest of time. Okay, so here I get 1 3/5. I don't want to say can't stand, but I just don't understand why this would be a mixed number, right? So let's just change this immediately to 8/5. And let's also add 1/5 to it. So then you get 3 square root of n is equal to 9/5. You multiply by 1/3. Notice how I like multiplying by 1/3 instead of dividing by 3, because we're already working with a fraction. So you want to get the square root of n is equal to 3/5. You can already tell that this works because the square root of n is a positive number. So then you square both sides, and you get n is equal to, now what's 3/5 times 3/5? Okay, so if I double check, I get 3 square root of 9 over 25 minus 1/5 is equal to 1/3. Let's see if that's true. Square root of n over 20, or 9 over 25 is 3/5. 3 times 3/5 is 9/5 minus 1/5, which is indeed 8/5. Okay, last one. So this is the first time we see a fourth. Oh, this is hilarious. It looks intimidating, right, class? Does anybody notice what I notice? What kind of a function is that? That's an even function. Even functions, even roots must always have a positive output. Immediately write no solution. It's hilarious. Fourth roots, square roots, doesn't matter. You can't have a root equaling a negative if it's an even function. All right, let's just say you didn't catch that. If you did fourth, you would get 3x squared minus 1 equals 1. And it would never, the fourth root of something should never equal negative. So I don't even want to go there, okay? Don't go there, just look at it. The fourth root of something, of an expression, must always be positive. And that is the lesson. And that is pretty much a wrap up of the entire module, class. This was a very, very important module. We learned about Pythagorean theorem. We learned about solving for x squared and x cubed. This page right here is excellent. I highly advise that you try this lesson. If you typically don't try the lessons and you just watch videos, that's okay. But I really think the homework will make a lot more sense if you do spend some time on these lessons. Okay. If you have any questions, I look forward to seeing you on, during our office hours, and let me know what you think. Take care.